Okay, before we start our die set, I want to use Solid Genius to explain what actions are. Here you see Solid Genius screws, and all the screws created by Solid Genius have actions attached, and it means that they can make their own holes. Let me take one Solid Genius screw, right, and just let me take like a dummy part, okay, and I will just show you on this dummy part how actions work. When I go to actions and select the screw, you see that there are 5 different actions: blind holes, through holes, counter bore hole, depending on the screw attached to the part. Okay, so what I do is I will copy this screw 5 times. On each part I will apply another action, because once we understand the actions, we will also see how can we use actions on the die set elements. Okay, so the plate has no holes. I have just positioned 5 times the screw into the full plate. I go to actions, select the part, and just one by one apply each action to the same plate. All right, here this was a simple hole. Second one is a tapped blind hole. See, blind hole which is threaded. And for the third part, here in this case of screws, of course the part will be always different. That's why we have to select the part each time when we apply. But on die set elements, we can automate the actions, and the actions can be automatically applied to one certain plate. We will see that very soon. Okay, the last part, I select this one. I select the last action, counter bore hole, and apply the same part. In this case, I can even move the screw automatically down. Alright, so these are the actions. Actions are, like I said, information attached to parts, and they will automatically create machining holes once applied. Okay, so when we go now, when we apply the same information to die set, okay, and in die set, you will also see many different parts, which can be useful for applying actions. For instance, let's check the information in die set. Okay, let me show you some possible parts where we can apply actions. Okay, for instance, here this part is creating 4 different, here this part is creating as well holes in different plates, or okay, the pilots or the pushers. For instance, the pushers are here. It's also creating its own holes, can create their own holes. Here we have the pilots. They also create different holes in different plates. And the good thing about these parts are we can define the plate automatically. We can say that this part, the pilot, for instance, is creating automatically the holes in certain plates. Let's look at this example now, how to apply actions, to our tie bars. Okay, I'll make a cut, and here we see there are. I just remove the elements. Here we have four different holes in 2 different plates. Okay, so now I will show you how to apply, how to define action, and how to apply them automatically to the plates. Alright, first I just uncut those parts so we can see their cylindrical faces. I select any face, and this red feedback object shows out the direction. So in this case, actually there's no direction. We can make the hole from both sides, okay? But I'll just take from the top direction and select the plate, take its name, and people can write the plate with minus or with underscore. That's why I use this while cut, and select the diameter. That's all. That's it. Now the action is applied. Same thing. I can just the action is okay to the part. This one, I just make a star. So okay, and then diameter is this one, and that's all. So now we have we defined actions on 2 faces. Here it's a little bit more complicated, because it's a direction is reverse. Okay, and now we have to say a machining feature which applies to this part. Again, I'm using this star as wildcard, so people can write piastra with underscore and with. Now I say I want to take this machining feature, and the parameters are automatically filled and apply automatically to the part. As you see, just select the face and set the direction, set the part to which it applies. Okay, and then I say machining feature exactly like this one. The parameters come to the editor, I look at them, say okay, that's all. So now we are finished. We have defined on 4 different parts actions. Okay, now how we can use it, I can just show you how to inquire, select the part, and you can see that there's one action, and this is a machining countersunk through hole. Alright, so now I will just go to the modeling and delete the existing holes, so there is no more hole left. And let's delete also machining features. Alright, now the fillet is full, and just to show you what we can do is I put all those 4 parts into a new assembly. Okay, this one, that one, and that one. So the 4 parts now I put into one assembly called A1. Right, so then I will just simply copy share this assembly to a new position. Okay, all right, now we are ready for applying the actions. I go back to progressive die design model and just simply select the apply actions function, and I don't select the parts, but I just select the assembly. I can say take all the parts and find all the actions in the assembly. These are 4 different ones. You see, applying 3 times to piastra superiore and 1 time to the lower plate. That's all. So means that, you know, all actions are applied to the parts correctly, and we are finished with the action definition. So the next step will be to save this tie bar into library and reuse it anytime you wish. Thank you.